Hello, ladies and gentlemen. My name is Joshua. It's my pleasure to welcome every one of us to the continuation of our study on the use of R for data analysis. In the last class, we tried to look at how to enter your data directly into R. But we all know sometimes you just have to import the data from Excel, from SPSS, from SAS, from Stata, or elsewhere. So to do so, that's where we're going to start today. The starting point is to put that your data in a directory. So which means you already have a folder where you have kept that your data. That is a very nice way to start learning data and imports. So let's set your working directory. You will come here, session. Then if you move down, you will see set working directory, choose directory. In my own case, I have this Excel plus R, that is the name of the folder, in my desktop. So that is where I have my data set and other documents. So click open. Now you click file here. So if you look at all this information, these are documents, various documents in the folder. So let us drag this down. I want to import a data titled supply chain data.csv. This is the data here. So you click on the data, you say import data set. Import data set. So this is the data set. Here you can change the name. Take for instance, to me the name is too long, so let me call it SS. If you change the name, if you look here, you will see that the name has not changed here. If you press import, your new name will not reflect. So you click somewhere else, anywhere. So now the name has changed. So the moment you discover that the name has changed, then you can import it. So you click on import here. So this is the data set. So let's return to our script file. And so let us start by getting the list of the variables. That's a list of the variables in SS data. To get the names, you just type names, and simple as that. Names SS. So run. So in this case, we have 25 variables. 1 to 25. Yeah. So there are certain built-in function for descriptive statistics. So let's look at the mean. You want to calculate the mean, simply mean. So mean SS, say dollar will give you the list of all the variables. And let us not forget that you calculate the mean of quantitative variables. So let's pick price. and run it. So the mean is 49.46246. Let's say you want, here we have how many decimal points? Is 5 decimal points. In case you want to reduce the number of decimal points, you start with options, digits equals to, let's keep it to 2. So run this, then run this. So when we say 2 digits, you can say that we have 2 digits. If we change this to 3, let's know, you can run the 2 together. Just highlight, and that saves time. You can see 3 digits, 4 digits, good. So it depends on you, the number of digits that you want to work with. So that is the mean. There's another type of mean that I want us to quickly look at. It is called trimmed mean. Trimmed mean. Trimmed mean. So when we talk of trimmed mean, sometimes arithmetic mean could be very sensitive to extreme values. Let me fix idea. Let's say you interview 3 people, and the age of the first person is 25. The age of the second person is, let's say, 25. And the third person is 100. If you add the 3 together, that will give you 150. You divide by 3 to calculate the mean. That will give you 50. And which means that the mean value is already greater than the age of 2/3, because that is 2/3 of them. So that is exactly how arithmetic mean is very, very sensitive to extreme values. And that is why sometimes people do work with median instead of mean. So sometimes you need to work with a mean that is more resistant. So in that way, we try to look at the trimmed mean. Trimmed means you delete certain outliers, that is, certain part of the bottom values and top values. So this is how it works in R. Let's say, let's call it still mean equals, okay, let's say T mean P, since we are looking at the mean of price, equals mean SS dollar price, comma, then you say trim equals, so you have to define the percentage that you want to cut off. If I want to cut off 10%, that would be 0.1. So run this, and you have your T mean P. Your T mean P now, run it. So you can now see that after removing 10% from 10% of the data sets of the bottom values and that of top values, your mean value has reduced to 49.36. Let's say I just want to cut off 5%, that would be 0.05. So then let's run the two together. Run. Yeah. And so on and so forth. So it depends on what you actually want to work with. Yeah. So that is just the difference between arithmetic mean and trimmed mean. Another type of mean is geometric mean. Geometric mean. Geometric mean. So when we talk of geometric mean, we apply geometric mean most of the time when we are dealing with growth rates. It works better than when we are considering growth rates. For details of the limitation, advantages, disadvantages of some of these measures of transfer tendency, you can go through that textbook on applied statistics for business. So it contains a lot of all this information. So geometric mean, to calculate it, let's call it G mean. So G mean P is equal to EXP, which is the exponential mean, then pick it log pick it. Then you have your SS dollar price. So let's run it. So our G mean, so G mean P is 34.6. 34.6. That is our geometric mean. Then we have harmonic mean. Harmonic mean. Harmonic mean. In terms of usage of harmonic means, it works better when we are dealing with ratio. In terms of various types of data that we work with, we have interval, we have ratio, we have ordinal, we have rank. We have ordinal. Ordinal also is ranking data. And then we have nominal. So if you go through any very good statistics for business and economics, definitely you will have all these things well explained. Or even nowadays, I think maybe you can use AirShite or Google to understand some of these things better. So harmonic means. So if you want to work with harmonic means, let us call it P, that is harmonic mean for the price. And that will give us 1 divided by the mean of the mean of 1 divided by excess dollar, and we are dealing with price. Yeah, so let's run this. So you have P here. So run it. So it's 17.4. So like I said, we use harmonic means when you are dealing with ratios or relative weights. That's very important. So let's move to another type, which is quadratic means. Quadratic. Quadratic. Quadratic means. So this is what is normally called root mean square. Root mean square. So it measures the absolute magnitude of a set of continuous variables. It works also with quantitative variables. And in R, it is, let us call it Q mean P now, since we are dealing with price. And that will give us SQRT. No, it's a root mean square. Then pick this. Then you have mean. Pick it. Then you have SS dollar SS dollar price, and then raised to power 2. This is the square. So let's run it. So you have your Q mean P. Oh, sorry, let me type it here. Q mean P. Then run it. So that gives us 58.38. 58.38. So that takes us to another measure of central tendency, which is the median. So the median. So it's an alternative measure of central tendency, particularly in the presence of outliers, just like when we're trying to use the trade means. The median is the middle value. That is the 50th percentile. So let's say med P, that will give us median. So median, then we have SS dollar price. So let's run it. So your MEDP, that is, so the median is 51.24. 51.24. Now mode. Yeah, for us to calculate mode, I'm going to teach us something new. Um, Usually when you install your R, some packages actually came with the installation. Those packages are called system packages. So click here, packages. So let's move up here. Here you have user library. Then if you go down, you will see system library. So there are two types of libraries here. We have the user library, then you have the system library. When you install R and RStudio, there are certain packages that we already installed. Those are called system packages, and they are located here in system library, such as base, boot, class, cluster, code tools, compiler, dataset, and so on and so forth. When we are typing, most of those things that we'll be doing, they are based on the system packages. That is, all those packages that came with the installation. But we have some packages that are contributed. They will not come with your installation of R and RStudio. Anytime you install such packages, they will be stored in what is called user library. User library. I've said this because now we want to use one of such packages in order to calculate the mode. And very soon we shall be dealing with quite a lot of such contributed packages. So the package that is normally used for mode is what is called cumstat, C-U-M-stats. Let's say you do not have it, then you come to Tools, Install, then you type the name cumstats. But you have to be sure that you are connected to internet anytime you want to install. After installation, you don't need internet again. You can continue to just work with it. Cumstats. So let me pick it here. Then install. So it will install the package. Okay, luckily it has installed it. So after installation, you want to use it, just type library cumstats. So if I'm working again and I want to calculate the mode, since I have installed this package, I don't need to install it again. I will just say library and continue to work with it. So run it. Excuse me. So the moment I have it now, I can just use it to calculate my mode. So mode. So you can see it mode. So SS dollar price. Run it. So it's 1. Oh, sorry. It's not 1. I think now, yeah. What he's trying to say now is that we don't even have any price that appear twice. So each of them have frequency of 1. Okay, let's try and use another variable. Let's say mode. SS dollar. So let me pick product type. So it is skincare and the frequency is 40. So because here we have, I think, three products. So skincare has the highest frequency, which is 40. Yeah. So that is mode. And that takes us to quartile. 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 A quartile describes the division of a set of observations into 4 defined intervals on the basis of the values of the data that we have. When we talk of median, that is division into 2, and you just pick the middle value. But when we talk of quartile, then we have divided it into 4 different types. So when we have Q1, so we can have Q1, which is 25% quartile. We have Q2, which is the median, that is 50% of the total number. And we have the upper quartile, that is 75% of the observation. So, and if you want to calculate it in R, the function is quintile. So let's say I need a quintile. Let's say 25p. So I need for 25% price. That is equal to quintile. Okay, I think we can calculate quintile p to save time. Quintile quintile. Sorry, quintile. Yes, quintile. It's in start package. It's part of the base package. Quintile. Then SS dollar price. So run. So Q tile P. Yeah, run. So you can see this is 0%, 25%, 50%, 75%, and 100%. So 25%, the first quartile is 19.60. The median, we have calculated it before, is 51.24. And the third quartile is 77.20%. Yeah, that takes us to percentile. Percentiles. It works almost the same way with quartile. It's a statistical measure indicating the value below which a given percentage of observations in one given group of observation fall. You know, we have 25th percentile, that is the first quartile, 58th percentile, that is the median, 75 percentile, that is the third quartile. And you may wish to have 10%, 20%, 30%, even 95%, depending on what you want to do. So if you want to calculate the percentiles, it's the same function, quantile, in start package that we will use. So let's say percentile P. Let's say p-tile P equals quantile. Then we have SS dollar. Let's pick price, comma. So let's say C. So now you define what you want: 0.1 for 10%, 0.2 for 20%, 0.8 for 80%, 0.95 for 95%, as you saw which. So let's run it. So, and let's say P, type P. So you can now see what we've done: 10%, 20%, 80%, and 95% percentiles. So, and there are various values. And that equals to interquartile range. Interquartile range. Interquartile range. Usually referred to as IQR, interquartile range. It's the difference between the upper quartile and the lower quartile. That is the difference between 75 percentile and 25 percentile. Yeah. What is the usage? Somehow, it's used to determine outliers. Low outliers are below the lower quartile, which is 25%, minus 1.5 multiplied by interquartile range. And when you are talking of maybe high outlier, then you are talking of those that could be said to be Q3 plus 1.5 multiplied by IQR. So think these are basic rules of thumb in statistics. So let us calculate the interquartile range. So now you can decide to just subtract the third quartile, the first quartile from the third quartile, and that will solve the problem. Or you use, so let me say IQRP equals, you can see the function is IQR. So pick it, IQR, SS dollar. Don't forget, like I said in previous class, R is highly sensitive to, it's highly case sensitive. So let's run this. Then you have your IQRP. So it's 57.6. 57.6. Yeah, so these are various statistics, and most of them are actually in built-in functions. In our built-in functions, they are functions in those packages that came when you install R. Now, let me check. It appears mode also is in this package now. But let me try it and see. Let's say so that you may not even need to install comstat. Price. Oh no, that is not it. This is the mode is like chain class. So I think we are correct to have used comstats. All right. Yeah. Now you may wish to obtain quick summary. I'm going to give you few of these statistics. So quick summary. Quick summary. So that would be summary. Geodata now. SS. So this will give us quick summary for all the variables that are covered. So let's move this up. There are quite a lot of them. Okay. So if you look at product type, here you see character. It's not giving us any number. This is because just like what we learned in the first class, the string, their character, their names. So that's why when we're dealing with various types of vectors, we mentioned a lot of characters. So these are names. That is why. Since you cannot calculate the mean of skin queer, hair care, and all sorts of things, or talk of color, blue or something. So these are qualitative variables generally. So in that wise, that's why you have it as character here. So for such data, what you actually need most of the time is the frequency counts and percentages. Okay. Yeah. So now we may need some other statistics. And again, this is not, we can't just export this to our Microsoft Word, because unless we just want to type it or copy and paste, which is not neat enough. So if you want to get better results, then we will need to use a package. And I want to introduce us to a package that can help us to do some of these exploratory data analysis. That is, we want to look at the basic characteristics and features of the data set that we have. So that takes us to EDAs using the EDA, exploratory data analysis. Exploratory data analysis. That's EDA, using Smart EDA package. So if you don't have it, don't forget, just as a reminder, just go to Tools here, Install Package, type the name, then install. But ensure that you are connected to internet before you can do it. So after that, you type library. Since I have it, I just use library to use it. So library Smart EDA. So run it. Then you will need another package, library Stargazer. Stargazer always help us to export whatever we have to Microsoft Word with ease. That is our tables and models. So let's say I want to create reports. So let's say creating quick reports. Quick reports. Of data sets. That is, we quickly want to show the overview of what the data is all about, the number of missing variables, outliers, some basic summary statistics, and sort of things. What you just need is export. That's EXP reports. This EXP reports. This is EXP reports. Then your entire data, comma. Then you define your output file, op_file. So you give it a name of your choice. Let me give it ss1.html. If you want it in Word document, you say .doc. So let's run this. Okay, so it's processing the reports. So sometimes we may have to wait a little bit, particularly when we are dealing with very large data sets. So, and the result will come up in HTML form. And like I said earlier, in case you want the results to come out in documents, then you use .doc. So this is the results, exploratory data analysis report. So these are the summary. You have the overview of the data. You have the summary of numerical variables, distribution of numerical variables, summary of categorical variables, distributions of categorical variables. Then you have bar plots for categorical variables. So you may wish to look at some of these results. So, and the beauty of it is this: you can actually use it in order to understand the coding, because you can, if you don't need everything and you just want to produce few of them, you can actually use the code. For instance, the overview of the data, this is the code that generates it. We have XP data, your data list, your data, and then type equals to 1. When the type is equal to 2, then you have the structure. So this overview is showing the sample size. We have 100 number of variables. We have 25, out of which we have 16 of them numerical, no factor variable. We have text variables, 9. You add that 9 to that 16, then that makes up to that 25. Then in terms of having complete cases, you have complete cases. So which means you do not have missing data. So in terms of the structure, this structure now uh, gives a clearer picture. So you have it this way. Your DMU is numeric, your product type is character, SKU is character, price is numeric, availability numeric, number of products sold numeric, and so on and so forth. So this is the total number of samples, and the missing, we don't have any missing, and so on. So you can go to 2 to see the next thing that is for the other variables, and so on until you get to the end. Yeah, then in terms of summary of the numerical variables, usually comes out with a lot of information. So this is the group. So, and we can even change the group to, if you have a target, then you have the total number of observation, number of negative, number of 0, number of positive, which means all the variables are positive, and so on. Then number of infinite, positive infinite, number of missing, percentage of missing, so and so on. So then you look at distribution of the numerical variables. You use this to test for the normality assumptions. This is our normal QQ curve. So, and as long as this line fall on this line, then we say the data is normally distributed. So the normality assumption is not violated, and so on. So we can see normal quartiles. So, and this is done for various variables. And I think this is the density function to actually show, it's another way of testing for normality. What you are looking for here is the bell shape. Yeah, then this is the scatter plots of the relationship between most of those variables that they appeared. So you have quite a lot of them. So you can, let's move this towards the end. So there are a lot of information. So, and these are the distribution of various categorical variables here and there. Yeah. So let's return to our R Studio. So that is, if you just want the report very quickly, but the beauty, just like what I said, you may wish to look at some of this report one by one instead of this general overview. And if you want to look at it one by one, so let's start with the data overview. Data overview. So for data overview, now you can call it a name since you want to do it. Let's say SS underscore OV. Want to look at the overview of the whole of SS data. That is EXP data. then SS, comma, type equals 1. Yeah, that's why by the time you look at the reports, you can see the code there. So it's so simple to learn. So run this. And you may wish to look at the results here directly. SS underscore OV. Let's move this here so that you can see clearly. Run. Okay. There are plenty variables. Let me move it a little bit again. Run. Yeah, I think there are many. Yeah. So, but so yeah, I think another thing we can do, we can actually export this to Microsoft Word directly, and that is the reason why we have this stargazer. So let me show us how this is done. Stargazer. You have SS underscore OV, comma. So you have type equals HTML, comma, summary equals false. The reason why I said summary equals to false is I just want the results just the way it appears here. If I say summary equals to true, it's going to re-summarize it. And that is not what I want. Then out, you have to give it a name. So out, yeah, let's call it SS underscore OV dot DOC, that is document. So let's run it. So run. So in order to check for your results, you can click on file here, file, and let me move this down. Update this. Just click on this except that is your folder. Just click on it. It will have updated it. Then you will look for this SS underscore OV, SS underscore OV, SS underscore OV. Okay, this is it here. So, and you can open it. So let's open it. Yeah, so this is it. Yeah, you can see it's very, very clear. So this is exactly what you need. So sample size, number of variables, number of numeric numbers, which I believe is always needed most of the time when you are trying to write your methodology. Yeah. So let's move forward. Let's go back to R. So you can see the beauty. So now let's look at the structure of the data structure, data structure, data structure. And like I said, let's say SS underscore str equals, just copy this to save time. Hey, I'm trying to save time, and in trying to copy, I'm actually wasting more time. So sorry about that. So copy, then here, paste. Just change this to 2. That's all. So run it. Good. And again, let's move it to Microsoft Word. Just copy this. Copy, paste, and let's change this to str, and this to str. So that's all. So then run it. Run. Beautiful. So again, you click here. This thing is blocking me. So click here to, yeah, beautiful. Then you now look for ss underscore str, ss underscore str. So this is it. So open it. So here you are. So you have what you want. Plenty of them. Yeah. So, and since you are here, you can delete whatever you don't want. For instance, now, I don't see any reason why I have to still maintain number of missing, 0. Number of missing is 0. So I need to delete some of those things. This index, now I don't even need these two. So you can do all those kind of adjustments using Microsoft Word. So let's come back. But the beauty is that now we're performing the analysis and taking our result to Microsoft Word with ease. So let's move a little bit more. So if you look at the general result, you have the summary of numerical variables. So let's try to do that also. Summary of numerical variables. Variables, not variables. Variables. Summary of numerical variables. So again, you have to call it a certain name. So let's say start statistics of numerical. Let's say start num equals in this case you have exp num, yeah, num start. You can see exp num start. So you pick it, then you have your variable ss. Then you have rand. Rand means I want my result to be rounded to a certain number of decimal points. So let me pick 3 so that my result will not go beyond 3 decimal places. Yeah, so if I have this, then you can run it. So run it. Beautiful. Now you may wish to look at your results. Let's check the results here first. So we have start num then run it. Yeah, in this case, you have massive results. You can see skewness, kurtosis, IQR, coefficient of variation, standard deviation, median. You have the mean, the maximum, minimum, sum, all manners. Yeah, so now I may not need everything. So if you don't need everything, the best thing is to just copy those ones that you need and use Stargazer to move those ones to Microsoft Word. This is the next thing we want to do. So let's call it stats num 2 equals, we have our stats num because we want to extract those ones from it. Then you use square bracket. Don't forget square brackets. Then comma. This command is talking of the columns. So you have to come here. Definitely you need variable names. So just make sure this is capital V. Just the way it appears. I need V names. Do I need group? I don't, because it's talking of all. Do I need TN? I don't need it because I know it's 100. N negative is 0, and this, I don't need all these things. So let me move to what I may need. I need the mean. Yes, I want to start with the mean. Mean is mean. I need the standard deviation. Check the way the standard deviation appear. It's capital SD. Okay, if you need the median, so let's add the median. So let's say I need a median, comma. I need the standard deviation, SD. Let me add just the minimum and maximum to this. I think that should be okay for me. Oh, since I have so many of them, so I think I need to add C. Yeah, please. I've forgotten that C. So you open a bracket here, and at the end of the day, you have to close it. Yeah. So I need the max, mean, then I need the max. Yeah, when you have too long names, usually I advise that maybe you drop some of them down so that you can see what you are typing. So let's say this is just what I need. Then you run it. It said undefined columns selected. So it's always good to look at so which column is not defined that I have selected. So sometimes you have to know what you have selected that is not just there. Okay. So let's go up again and trace what we've done wrong. You can see it's V name, not V names. That's a mistake. So yeah. So run it again now. Beautiful. It's correct. So now, just to save time, let's copy this stargazer here. Copy. And paste it here. So then we change this to start num, and this becomes start num. Start num 2. Start num 2. Start num 2. Yeah. So let's run this. So again, I can even move it here to see. So just click on this. It's already updated. So I'm looking for start num. Start num. Start num 2. So this is it. Start num 2. Yeah, super clear. So this is the variable name, the mean, standard deviation, minimum and maximum. So for all the variables together, so there are plenty of them. So you can select those that you want and delete those ones that, but very sure they are not of interest to you. Yeah. So let's return also to our R. So we can move this sideways so that we can continue the coding. So what we've done is just the summary of the numerical uh, variables, and we have not assigned any form of targets, but maybe we should still omit the use of adding targets, because when we add targets, definitely it's going to give us either correlation or chi-square or sort of thing. So I think when we get to hypothesis testing, we'll be doing that. So I think now let's look at summary of categorical variables. Summary of categorical variables. Summary of categorical variables. Now the starting point is to obtain the frequency count and percentages. I think that is the starting points. So we do it without any target first and see how the result looks like. So let's call it freq, a frequency table. Let's say freq t equals is exp c8, yeah, c table, exp c table. That is, the function is maths PDS. Then our data is ss. Then round. So let's round equals to 2. In this case, we need percentage. So percent is per. So per equals to t. Yeah, so run. So we may wish to look at the results before we export it. It's always very massive too. So we have freq Sorry, we have T. So so let's run it. Let me shift this down here. So run it. So here we are, quite a lot of them. So move up. Yeah, so I want to show us how the result looks like. So you have the variable, the valid um, frequency, then you have the percent, then you have the cumulative percentage. And it shows the result for all the categorical variables in your data set. The beauty is that the smart EDA package will extract all the categorical by itself. So let's say we want to move this, just let's say Stargazer. Copy. And let's place it here. Paste. So here we have freak T. And here we have freak T. Yeah. So we run this. So beautiful. Yeah. So, and again, let's shift this here. Then double click on this or just click on it. So I'm looking for freak T. Freak T. So this is it. Yeah. Just double click. So here we are. You have all of them. So depending on your interest, if I'm looking at just at the product type, it's just cosmetic, hair care, and skin, frequency, percentage, the cognitive percentage. If it's customer demographic, female, male, non-binary, or no, and so on. So you have all the frequency distribution here, all of them, all of them. Yeah, and let's take one more in terms of the frequency distribution, in terms of frequency count and table. Now, let's say we are working, maybe we have a target, for instance. Let's say we want to look at the distribution by product type. You know, we have, if you look at the results of what we have um, 3 products. We have hair care, skin care, and cosmetics. So let's say we want our results by various groups. You can see it's clearly there. Availability by group, and a lot more. But let me show you how this is done, because the previous ones, we do not define the group. So let's say we want to define the group, and so if you want to do that, let's go back to RStudio. So that would be frequency frequency distribution by group. Frequency distribution of categorical variable, CATVA. So again, you can just copy this to save time. This is freak this. Copy. So you come here, paste. So the only difference now is that you have a target. So you say target equals to. So let us make product type our target. Product type. So products, you have to be sure this you don't miss the spelling. Product type, comma. Yeah, so this is just the difference. So, and if you have done this, then you can just you can run straight away. So let's run this. Let me move this sideways so that we can see clearly the results. So run. So, oh, let me call it another name. So let's say freak T2 to distinguish it from what we've done the other time. Run. So I say freak T2. So run. Yeah, so plenty results also. So in this case, you have the results by various, you have the results of product type by various other categorical variables. You can see demographic, so there are a lot of information here actually. Yeah, so let us take it to Microsoft Watch to see clearly how the results look like. So let's use Stargazer. Just copy this. Place it here. And let's put 2 here. Yeah, I think that's all. So run. Okay. So we can. Oh, yeah. We cannot append this. So put 2 here. Yeah, beautiful. So move. So we are looking for freak T2. Just work on this again. Then you have freak T2. So this is it here. So open it. Yeah. So you have cosmetic, hair care, skincare, and you have all the other variables. So this is actually showing clearly the cross tabs. So and you have it for all the variables, all the quantitative variables. So this is how it is done. So, and I believe in terms of representing our frequency distribution, summary statistics by table, or trying to just calculate each one, such as mean, trade mean, harmonic mean, this is just what you need. And this takes us to the end of this second class. Thank you for your patience, and please try to go over this and replicate what we have done. Thank you very much.